Hi everyone, welcome back to online video lecture. This is Sachin Kumar doing PhD under the guidance of Dr. Kaustubh Kulkarni in Department of Material Science and Engineering, IIT Kanpur. And my current research topic is diffusion in nickel ternary alloy, nickel based ternary alloy. Today's new lecture video series is about introduction to the ferrous alloys. In this video lecture, we will start with the overview. So in this video lecture, series of video lecture, we will know about the classification of the ferrous alloy. So how this ferrous and non-ferrous alloys are classified, and this classification of a steel and cast iron and its microstructure. Microstructure, alloying element, and application. Of these alloys, ferrous alloys. So we will know brief introduction to these ferrous alloys. This video lecture is mainly about the theoretical based and informative video. So it will use MCQ questions to answer the MCQ questions in the various competitive exams such as local state exams or GATE exam. In GATE exam, we can answer the answer for this material science questions can be answered very easily with these video lectures. Okay, let us begin with the classification of the ferrous alloy. So why we need to divide this metal alloys into two parts, that is a ferrous as well as non-ferrous. The ferrous means abundantly contain the major prime constituents is iron. Iron is a prime constituent, and other alloying elements such as carbon, nickel, vanadium, chromium, very small trace quantity are added to improve its properties, so that we can get the wide range of applications and wide range of mechanical properties. And this is ferrous alloys. Non-ferrous alloys such as aluminium, magnesium, nickel, copper. So many alloys are there. So we can divide ferrous and non-ferrous alloys. And again, so non-ferrous alloys we will learn in other video lecture. In this video series, we will know about, we are concentrating on the ferrous alloys. The ferrous alloys again divided into steel as well as cast iron. Okay, so first series is steel. Steel is divided into low alloy steel and the high alloy steel. The low alloy steel consisting of three subdivisions, that is low carbon steel and the medium carbon steel, high carbon steel. The medium carbon steel, all the three consisting of one common thing is plain. That means no other alloying elements are added in this one. So only the varying the percentage of carbon, we can get the three different alloys with in the iron. So this is no other alloying elements are added. When we give some heat treatment or other adding other alloying element will give a different kind of an alloy. Hence, they are divided into another category, that is high strength low alloy steel. So, adding a small quantity of the low carbon steel, we will get a very high strength that I will explain in the further video lecture. And this medium carbon steel can be heat treatable. So, after heat treating, there is a different kind of an alloy we will get. Hence, they are classified into another classification. And whereas a high carbon steel, they are again divided into tool steel tool steel. And whereas a high alloys containing steel are divided into stainless steel. Stainless steel mainly consisting of 11% of chromium. So, due to this, it has a corrosion resistance property. We will see so in detail about this stainless steel in this video lecture. This is a whole classification of a ferrous alloy. Sorry. So next we will have this cast iron steels. This is the classification. It's a very large tree is there. So after this, cast iron is having very small tree. Again, it consisting of gray iron, ductile iron, white iron, and malleable iron. So name here, the names are unique, and these names have a unique property. Due to this property, their names are given. For example, gray iron. So when we uses the gray iron, if there is a fracture in the surface, fracture in the material, they breaks into two parts. The fractured surface appears as a gray. Hence, it is called as a gray iron. This kind of thing they have observed and they given the names. So, on the basis of their property, on the basis of morphology, they given the name for the cast irons. Right? So, we will get into the in-depth of these two, steels as well as cast iron. First video lecture, I will deal with this steels. Next video lecture series, I will deal with the cast iron. Okay, introduction to the steel. As I said, from the iron carbon diagram, I will draw little bit one just brief recap, that is iron carbon diagram. Small portion I will draw, not whole the thing. Okay, so this is okay, this is 2.16. So below this one they are called as a steel, above this one they are called as a cast iron. Okay, this is the portion where we are studying now, steel. So we are varying the concentration from 0 to 2.16 of carbon. So from varying only the 2.16% weight percent of a carbon, we will get the wide range, thousands of materials, thousands of a steel alloys will get. So hence, due to this, it's a very interesting to study the steel. Wide range of mechanical properties we will get by varying the concentration of the carbon. We know, so steel, where the steel will lies in the iron carbon diagram. Okay, so let us start with a plain carbon steel. So plain carbon steel, in which only residual concentration of the impurities or other than carbon, very little amount of magnesium is present. only the trace quantities of alloying elements, that is magnesium, is present. Uh, Other than this one, only the carbon is present in this one, this plain carbon steel. Hence it is present in plain, as the name indicates, plain. Nothing is there except carbon. So steel came because of lesser quantity of carbon, that is below 1% it is having. Again, so we have divided low carbon steel, high carbon steel, medium carbon steel. Okay, so steels are divided into three parts: low, high and medium. So we will start with a low carbon steel. Low carbon steel contains a less than 0.258% of the carbon. And it's very difficult to heat treat to get the martensitic structure. But we can increase the strength of this carbon, strength of the low carbon steel, by the cold working process. By cold working process, the strength of the material is increased. So how this strength will increases with the help of cold working, we will study in the chapter of next upcoming video, that is so we will study how this cold working will helps to increase the strength of the material in the chapter called as a strengthening mechanism. So this cold working will increases the dislocation density, and it will helps to restrict the movement of the dislocations. And this is a mechanism. Lot process is there. So we will learn in the strengthening mechanism of alloys. So what is the microstructure of a low carbon steel? Is it consisting of a ferrite as well as a perlite. This is the main constituent. Due to, as we know this, ferrite as well as a perlite is a soft and very weak in material, weak in the strength as compared to the strength, but they are more ductile and more tough. So what do you mean by tough? It is having, this is stress strength. Okay, this is stress strength. It's outstanding toughness. It's a more toughness means it can absorb the more energy before the fracture. So it can be stretched more. It is 25 up to 25% it can be stretched. So main advantage of this low carbon steel is they are machinable, weldable and less expensive. This is the most important. So most of the steels and other alloys or non-ferrous alloys are more expensive because of the more expensive. Okay, it's a more ductile. That means it's a more, it can be elongate more. That is elastic EL is 25%. And because of this ductility in nature, it can be used in many applications such as automobile body components, structural shape components. They can be made as a thin sheets because of its ductility in nature. So thin, it can be made as a thin sheets. And the bridges and the Pepsi cans, Sprite cans which we used to drink casually, they are made up of a low carbon steels. Because of this, it's less expensive. They can be used in the tin cans and other things. More attractive, right? So when we will see the mechanical properties such as yield strength, it varies from 275 megapascal to the, and the tensile strength is lines between 415 to 515 megapascal. As I said, the ductility is 25% of elongation. This is a brief introduction to the low carbon steel. This is the mechanical properties, microstructure and applications of a low carbon steel. When we are adding very less quantity of an alloying element such as copper, vanadium, molybdenum, that's as about 10 weight percent, there is a drastic change in the mechanical properties. This strength is enhanced as compared to that of the low carbon steel. Strength is enhanced, that means the tensile strength will increase access to that of the 480 megapascal. Due to alloying elements, they are more resistive to the corrosions and they can be used in the many applications such as bridges, towers, supportive columns and high-rising buildings. And the pressure vessels, they are also made up of high strength alloys, high strength low alloy carbons. These will have low cost and a high strength and more application. Because of this one, they can be used in many applications. Okay, this is all about the low carbon steel and the high strength low alloy steels. Okay, so when we are getting into the next topic is medium carbon steel. As the name indicates, the carbon content lies between 0.25 to 0.68% of a 0.68%. The final microstructure that is consisting is tempered martensite. They can be easily heat treatable, right? They can be easily heat treatable with the help of an austenizing process. So austenizing process, they will quench it and then tempered it to improve its mechanical properties. Due to this heat treatment, the final microstructure is, we will get it as tempered martensite. Tempered martensite. And this plain medium carbon steel, that means very only consisting of a carbon, no other alloying elements are present, are having low hardenability. So one question is, what do you mean by hardenability? The hardness is different, hardenability is different. Hardenability is the ability of this material which it can form a martensitic structure, easily with which it can be formed a martensitic structure. This is called low hardenability. Low hardenability, with the help of, I can explain with the help of TTT diagram. So TTT diagram, this is okay, martensitic structure that is forming. It is having low hardenable, it is having high hardenability. So this means ease with which it can form a martensitic structure. It is very difficult with a very less time. This is time and temperature. It is having temperature and time. Okay. So with very less time, with a speed quenching, we can get the martensitic structure, which is very difficult here. So that's why it is having low hardenability. So here it is having very more amount of time to get the Martin's-Reed structure. Hence it is, which is very easy. Correct. So quenching with only 1 second, 2 seconds is very difficult. Rather than 10 second and 20 second is very easy. So hence the Martin-Reed structure can be formed very easily. Hence it is having the high hardenability. This is a funda of hardenability. In most of the interviews, this question will be asked commonly. So please concentrate this one. It is having low hardenability, and hardenability can be obtained. The Martin-Reed structure can be obtained with a very thin sections. Plain medium carbon steel. Because of this one, they have added with the chromium, nickel, and other alloying elements to improve its heat treatment, so that it can increase its hardenability as well as its mechanical properties. So for such as chromium, nickel, molybdenum will be added to enhance its properties. So okay, so hence the final is application. So application, due to its high strength and more ductile and more toughness, they can be used in gears, crankshafts, and other machining parts where there is a high strength structural components have been used. It is also wear resistance and more tough. So hence they are used in many applications, structural applications. This is a microstructure of a plain carbon steel, which is explained in the previous slide, and this is a microstructure of the medium carbon steel. This is a paralytic structure, and this is alpha ferrite. Both they are present, and the tempered Martin-Reed. So final classification of the steel is high carbon steel. We have steel till now. We have seen low carbon steel, high medium carbon steel, okay. So now the turn is high carbon steel. As the name consisting indicates, it consisting of a more amount of a carbon, such as it is from 0.6 to 1.4 weight%. Usually we are using up to 1% weight%. That's it. As we are increasing the carbon concentration, so hardness as well as strength is increased, but we are reducing, compromising with the ductility. So they are less ductile but more harder and stronger as compared to that of the other two steels. Hence they are used in the wear resistance, applicable to the holding the sharp cutting edges. They are mainly used for the cutting tools. Tools and die materials are made up of this high carbon steels. But to improve, as the carbon, not only carbon will increase its strength, other alloying elements such as chromium, vanadium, tungsten, molybdenum will increase its strength. So when we add chromium, molybdenum, they will react with the carbon at high temperature. They forms Cr23(6). Intermetallic they will form. Vanadium it will form, and this type of intermetallic components will enhance its mechanical properties of a high carbon steels. Because of this one, they can be used in the hacksaw blades, springs, and the high strength wires. So wide range of application is there, but only when there is a high strength and wear resistance is needed. But they are very least ductile as compared to that of the other. According to ductility, so increasing ductility. So we can write it as high carbon steel having least, medium carbon steel, low carbon steel. So hardness is reverse. Okay. This is the most important thing. This series can be asked in many of the exams. So least rearrange the following alloys in the increasing order of the ductility or decreasing order of the hardenability. So many things they can be asked. Okay. So next part we will explain. We will discuss in the next upcoming videos. Thank you.